Hello students. Now let us go through some more sums where there are variables in the denominator. In the previous sum there was x, y, xy in the denominator. We could easily multiply throughout by xy. We could get rid of the denominator, right? We could multiply throughout by the LCM. Now let's see what is in store for us as far as the next sum is concerned. This time the sum is solve the following simultaneous equations. 2 upon x minus 3 upon y is equal to 15. 8 upon x plus 5 upon y is equal to 77. So this time the two equations given to us are 2 upon x minus 3 upon y is equal to 15 and 8 upon x plus 5 upon y is equal to 77. There is something missing in this sum as compared to the previous sum, right? Yes, the denominator is only x and y. There is no xy in the denominator. Now, how will it actually change the entire sum? Please try to understand this. See, first of all, let me tell you, mathematically, you can solve the given equations in the current form also. There are no restrictions. You will get the answer. With x and y in the denominator, you can actually solve it. But the problem is, when x and y are in the denominator, the degree of the equation is not 1, the degree of the equation is minus 1, law of indices. And because the degree of the equation is not 1, the given equations are not linear equations. But the name of the chapter is linear equations. So as per the rule, we need to first convert these equations to linear equations. That's the reason we cannot solve them in the current form. But mathematically it is allowed. But as far as the exam is concerned, because the name of the chapter is linear equations, we need to form linear equations and then solve. That's the first thing, right? That's the issue basically. Now you all must be wondering, let's multiply throughout by xy the way we did in the previous sum, right? You can, but the problem will be when you multiply throughout by xy, 2 upon x into xy, xx will get cancelled. No problem, denominator goes. 3 upon y into xy, yy gets cancelled. No problem, denominator goes. 15 into xy is 15xy. There is no xy in the denominator that it gets cancelled. So that xy will remain, 15xy will remain. And let me tell you, there the problem is, xy is again not a linear term. That's why we cannot multiply throughout by xy here, because when we do it, that one xy will remain here. Again, mathematically, you will be able to solve, but not allowed because the name of the chapter is linear equations in two variables. So, in this sum, because there is an xy missing in the denominator like the previous sum, you cannot multiply throughout by xy, otherwise that xy will remain and it will not still be a linear equation, right? So, you all got the problem. Now, what is the solution? Always remember one thing, whenever you have a sum like this, that you have variables in the denominator and you are not left with the option of multiplying throughout by the LCM, that is xy, then the only thing that we need to do is we need to substitute something and make it linear. Now the question is, what exactly are we supposed to substitute? So one thing, whenever there are variables in the denominator and we don't have an option of multiplying throughout by xy, the only way of making it a linear equation is by substituting something. Right? Now, what are we supposed to substitute? Let's try and understand that now. Now, see, the first equation is 2 upon x minus 3 upon y is equal to 15. Now, can we write this 2 upon x as 2 into 1 upon x, one and the same? 3 upon y can be written as 3 into 1 upon y, right? Let this be the first equation. Similarly, 8 upon x is nothing but 8 into 1 upon x. And 5 upon y is nothing but 5 into 1 upon y. Let this be the second equation. Now look at both the equations. The first equation is 2 into 1 upon x minus 3 into 1 upon y is equal to 15. The second equation is 8 into 1 upon x plus 5 into 1 upon y is equal to 17. Now look at these brackets. In both the equations, can we say these brackets are common? Can you see 1 upon x is common? 1 upon y is common. Now because 1 upon x is common and 1 upon y is common in both the equations, we will substitute 1 upon x as say m and 1 upon y as say n in equations 1 and 2. Now what happens when we do it? Let us now replace 1 upon x in both the equations by m and let us replace 1 upon y as n. Now what do we get? 2 in place of 1 upon x, now we need to write m. So what we get is 2m minus 3n, right, is equal to 15. Let this be the third equation. 8m plus 5n is equal to 77. Let this be the fourth equation. And look at these two equations now, the third and the fourth equation. Are we not getting two linear equations in two variables? Now we can solve this by any method. We generally prefer equating the coefficients method in this. So remember this is a new thing that we learned. Wherever there are variables in the denominator and you don't have that option of multiplying throughout by x, y, the only thing that you need to do is you need to substitute something. Substitute what? Substitute whatever is the common denominator. See, x in the denominator, 1 upon x is equal to m. Y in the denominator, 1 upon y is equal to n. So you just need to look for the common denominators in such sums. X, common denominator. So 1 upon x is equal to m. Y, common denominator. So 1 upon y is equal to n. Substitute 2 upon x minus 3 upon y is equal to 15 will become 2m minus 3n is equal to 15. 8m plus 5n is equal to 77. Now let's quickly solve this by the method of equating the coefficients. You already know this method, so we can just quickly run through this method. Look at the coefficients of m, the coefficients are not same. Look at the coefficients of n, the coefficients are not same. So let us make either the coefficients of m same or the coefficients of n same. In this, it is very clear that it is easier to make the coefficients of m same because the coefficients are 2 and 8. So it's easy to multiply the third equation by 4 and make it 8m, right? So let us multiply the third equation by 4, something which we have learned previously, right? So we can just go through it a little faster. So we get 8m minus 12n is equal to 15 into 4 is 60. Let this be equation number 5. So we just modified the third equation by multiplying by 4 and we got the fifth equation. So now whatever operations that we will be doing will be between the fourth and the fifth equation, because in fourth and fifth equation we have successfully made the coefficients of m same. And because the coefficients of m are same, we can eliminate m. For that, check the signs. It is plus 8m, the signs are same, so we need to subtract. Let's subtract 5 from 4. When we subtract 5 from 4, you need to write the fourth equation first, then you need to write the fifth equation, and then don't forget to change the signs. Plus 8m will become minus 8m, minus 12n will become plus 12n, and plus 60 will become minus 60. 8m will get cancelled, plus 5 plus 12 will be plus 17, and 77 minus 60 will be 17. 17n is equal to 17, so n is definitely equal to 17 upon 17, so n is equal to 1. Once you get the value of n as 1, once we get this, let us substitute n is equal to 1 in either of the two equations and we get the value of m. So let's substitute n is equal to 1 in, say, equation number 3, and we get 2m minus 3 into 1 is equal to 15. So 2m minus 3 is 15, 2m is equal to 15 plus 3, 2m is equal to 18, m is equal to 9, right? We got the value of m, we got the value of n, but the sum is not yet over. Why? Because in the question, the variables are x and y. So our ultimate aim is to find the value of x and find the value of y. M and n were used just to convert the given equations into linear. So what we did, we substituted 1 upon x as m, 1 upon y as n. We solved, we got the value of m and the value of n. Now to find x and y, what we need to do is we need to resubstitute the values of m and n. Wherever there is a substitution, there has to be a resubstitution, right? Now let's resubstitute the values of m and n. When we say resubstitute the values of m and n, meaning m is now resubstituted as 1 upon x and n is now resubstituted as 1 upon y, right? So in place of m, it is basically 1 upon x. So m is 9. So can we say 1 upon x is equal to the value of m, that is 9. That's the resubstitution. M is 9. So 1 upon x is 9, resubstituting the values. Similarly, n is 1. In other words, 1 upon y is equal to 1. So 1 upon x is 9 because m is 9. So 1 upon x is 9. And 1 upon y is 1 because n is 1. N is 1. So 1 upon y is 1. Resubstituting. 1 upon x is 9. But what we want is we want the value of x. So to get x from 1 upon x, we just need to take the reciprocal. So 1 upon x becomes x and 9 becomes 1 upon 9. So if 1 upon x is equal to 9, x will be equal to 1 upon 9, reciprocal, or you can also cross multiply. X will go up, 9 will come down. So x is equal to 1 upon 9, right? So if 1 upon x is equal to 9, then x is definitely equal to 1 upon 9. And if 1 upon y is equal to 1, y is also equal to 1 because 1 reciprocal is 1, right? So x is 1 upon 9, y is 1. Just write the final answer. Solution of the given simultaneous equation is x comma y, which is equal to 1 upon 9 comma 1. So whenever we see variables in the denominator, no option of multiplying throughout by x, y, go for substitution. Substitute the common denominators. X in the denominator, 1 upon x is equal to m. Y in the denominator, 1 upon y is equal to n. Substitute, you will get the two linear equations. Solve it by the method of equating the coefficients, which we just did. You already know that method. You will get the values of m and n. But the sum is not over because wherever there is a substitution, there has to be a resubstitution. So resubstitute the values. M 9, so 1 upon x is 9. N 1, meaning 1 upon y is equal to 1. Resubstitute, take invertendo or cross multiply, get the values of x and y, write the final answer and get full marks. As simple as that.